So today our guest speaker is Calder, and he is going to present the importance of regenerative agriculture. So for those who didn't attend the environmental panel, Calder is the founder of P3 Permaculture, a company that provides easy access to permaculture education and promotes the sustainable design solutions for different environments. Also, if you have any questions during the workshop, you can send them to me privately on the Zoom chat. Just click on chat and select to everyone and select my name, Regenerative. And because after the workshop, we'll have like probably around 10 minutes of Q&A, depending on the time. Now I'll let our speaker continue with his workshop on regenerative agriculture. So Graham, the floor is yours.
All right, thank you, Regis. I would also like to suggest that, very often we end up getting a lot more questions than we can handle. So if feel free to drop all your questions. If we can't get to them, then what I would propose is that if we can collect the questions, then maybe I can do a quick video snippet afterwards that's just answering the rest of the questions that we can post on the social media after the event. So to get started into this, really, permaculture is the angle that we're taking today, which is a word that not many of us will know. So we're going to work our way into permaculture, but starting through the ecological agriculture lens. The presentation that I prepared is fairly concise, but it's just to give you really the examples visual of what's going on around the world. And to help us to better understand what we're facing. So regenerative design is a better word to start with when we're looking at regenerative agriculture and permaculture, because permaculture is really a design science that's used to solve problems that we're facing, and not just agricultural problems, but they can be business design and setup, they can be actual structural for your home, they can be many different forms of application, technological or whatnot. So today we're going to really focus on the agricultural perspective. So permaculture is a process of design that's based in this observation of nature. And to begin, we're going to start back a few steps away from agriculture, because we do need to make sure that we're all on the same page through the observation of the world today. And that observation that I want to hone in and highlight is one that's kind of been drowned out by the latest COVID crisis that we are all living through. And the scale of this climate change challenge that we're all facing is something really important to start with as a baseline, because we often talk about the Paris Accord, we often talk about this famous 2 degrees Celsius as what we are going to achieve. And the media often even used to, before COVID, mention that we have 10 years to really begin implementing change to be able to get to this 2 degrees Celsius. To start with, the 10 years is that we have to fundamentally change every aspect of transportation, every aspect of heating and cooling our homes, every aspect of food production, and basically every aspect of the urban life in order to achieve 2 degrees Celsius within 10 years. So it's not to begin within 10 years, it's that we need to have this fundamental transformation done and underway in that time period. If we look at where we are actually on track today, first of all, if we look at the probability of exceeding 2 degrees Celsius, it's 90% based on what countries and different organizations around the world have committed to. And the probability of exceeding it based on what people are doing. So the first 90% is what people say they're going to do. And then based on what countries are actually doing is a 97% probability that we are going to exceed 2 degrees Celsius. So what does 2 degrees Celsius mean? It's a very vague concept to understand, global average temperature. But to give you a reference point, if you can imagine where you're sitting today, if you are in North America, and you would be 15,000 years ago beneath 12 kilometers of ice. The average global temperature 15,000 years ago, to give us that ice age, would be 4 degrees Celsius lower than it is today. So if a decrease of 4 degrees Celsius over a period of 3,000 years can give us a massive ice age, then what does a 2 degree increase look like over 80 years? The unfortunate reality is that we're on track today with the way that we're going with not business as usual, because we've increased emissions beyond business as usual, but we are on track right now for a 7 degrees Celsius increase within the next 80 years. There isn't actually even very solid data of what 7 degrees warmer average temperature looks like, but there is some data for 5 degrees Celsius. So the map that you're seeing in front of you, where Montreal is under the ocean and so is Lake Ontario, this is what sea level rise would look like with a 5-degree increase of global average temperatures. It's 100 meters or 300 feet of sea level rise. So when we ask the question about sustainable agriculture, we really need to consider all of these impacts as well, because as Carolyn Begg mentioned in the panel earlier today, the externalities are not measured when we actually measure the efficiency of productivity in agricultural systems. So now that we all have that baseline, we got to start looking at how to fix the problem. In permaculture, we always identify the problem and then break it up into its components. The problem here is carbon dioxide and other greenhouse gas emissions that cause the greenhouse effect. So where do they come from? If we look at the graph, forget about everything except for the two major sources here of electricity and food and land use. That covers about half of our input of greenhouse gases into the atmosphere. So if we today are going to look at land use and agriculture, we can understand that the way that we use the land today for food production and for parks and for forestry is going to impact 24% of all the carbon dioxide and greenhouse gas emissions that we emit. So it's a huge step just dealing with our land and our food. If we then look at the sink, which is where the earth has the ability to absorb carbon dioxide and store it out of the atmosphere, preventing any change, actually, again, 24% of that is in the land. So the earth has the ability as a sponge to absorb the CO2 in the atmosphere, and the only other source or sink that is greater than that is the actual ocean itself. So by tackling food, we are tackling upwards of 24% of the input and the sequestration of carbon around the world, which is a really massive thing. It's not like turning your tap off when you're brushing your teeth. Like, these are very impactful decisions that we are choosing to make with our food production. COVID has shined another light on what we're dealing with globally as food security, elder care, childcare, and food distribution have come into the limelight. We look at cases in Canada, and there's a lot of discussion as to why we didn't close the borders with the US, especially because of the US's mishandling of this. And the reason why is because we would starve to death. There isn't enough food supply and obviously other resources, but food supply is a basis within the country of Canada, even though for our population ratio to arable land, we have more than enough land to produce everything we require as a nation. So there's a lot of this that has come into the line 11 years. And in every country, food security, land degradation, erosion, flooding, climate change are all huge problems that are exacerbating poverty, exacerbating illness, they're exacerbating all kinds of issues. So when we focus on regenerative agriculture, then we're really tackling not just a food problem, not just a nutrition problem, not just flooding, but we're tackling various different problems that aren't even addressed in this discussion about regenerative agriculture. So to start with, now into the content, when we talk about regenerative or ecological agriculture, the question that often comes up is permaculture able to feed the world? Or is regenerative agriculture able to feed the world, or ecological or even organic agriculture? And I love this question because it is a very important focus as to where we get our information from. Because the people that are asking this question are the universities around the world and the media organizations around the world, because they have funding from industries that want this question to be asked. The reality is that we need to ask the opposite question. Can conventional agriculture today actually feed the world? And we're going to start with this counter observation before we then look at how regenerative agriculture can more than feed the world. So today, we currently produce 30% of the world's food supply with conventional industrial agriculture. Most of us, and if we were in Google Meet, I would ask you to drop me a thumbs up. But if you thought that the industrial agriculture complex produced the majority of our food, most of you would be in agreement, right? This is what we tend to learn in agriculture, what we tend to learn in university, and our media talks about as well, that these big industrial food complexes are what feed the world. When reality is that they only produce 30% of the world's food supply, and actually that number was updated just, I updated it. It's actually only 25% of the food supply, as now 75% is produced by small farms. This 30%, I'm going to run with these numbers because this is what I have for my example. The 30% of the global food supply, in producing that with the industrial, this is also like GMO, it's also industrial wheat, it's also industrial, other forms that are not necessarily GMO. But if we wanted to produce 100% of our food with this technique, let's say we triple it and get to 90%, that'll give some easier math, then we actually have to increase the greenhouse gas emissions of this industry by 90 to 130%. So it's an impossibility to increase the productivity of this type of agriculture in a way to meet the demand of our growing population, because of the simple fact that the industrial agricultural complex produces, for every 1 calorie of food, it requires 10 calories of fossil fuel energy to actually produce that food through transportation, fertilizer, and other amendment production, and the transportation, processing, and cultivation. So this model itself has some inherent flaws that we need to look at. If we look at the stats that tell us that we need to have a 70% increase in food supply by 2050, well, if we just had a 50% increase in food supply, well, then we're looking at 180 to 260% increase of our greenhouse gas emissions. So there's absolutely no way that the conventional industrial model will be able to produce food for us without reaching that 7 degrees increase in temperature. Actually, not even, because the 7 degrees increase is what we're already on track for. So if we're getting a 200% increase in greenhouse gas, it's not going to happen. So when we look at land is actually a carbon neutral or carbon negative, system, where it absorbs more carbon and stores more carbon long-term in its structure than it emits in its natural growth cycles. But as soon as you till that, you're adding oxygen underground, which kills a large portion of the organisms underground, which are carbon-based. And as they die, that carbon dioxide is released into the atmosphere. And when you till the land for the first time from an ecosystem into a farm, you're releasing 55% of the storage of that land, of the carbon that was in that land. And if we look at the graphs from earlier, 24% of the world's carbon is in the land. So it's a massive vulnerability there. If we think we want to increase agricultural productivity, which means clear cutting more forests and tilling more land, there is no way to do that through the conventional model. We are out of options. It's run its course, and it's we often joke about it being, the model itself is like a drug addict that is, every dose is getting you closer and closer to death, but it's required to maintain the habit. And so we need to break free from the habit, and we need to break free from this system. And we can do that by looking at all of its flaws and then addressing those flaws with solutions. So another element of conventional agriculture is not just the carbon impact or the greenhouse gases, but if we look at these circles, this was back, so the image that we're looking at here is a center pivot irrigation system. And these are often done in the central US, in California, in Saudi Arabia, in large areas of the world that don't have access to lots of surface water. So at the very center of this, there's a deep ground pump that is pulling water from the underground aquifer, which takes a huge amount of time to replenish. And then they're spraying that water over the crops to irrigate. So you can see that the irrigation kind of goes in a circle back and forth all day long. Well, if we look at this satellite image of it, and you can actually go on Google Earth and find these images, you'll notice that quite a few of these blocks of land are white. They're completely white. Now, this isn't land that is tilled. You can see the brown areas. Those are areas of land that are tilled. The white areas are areas of land that have had so much overhead irrigation during the daytime that the evaporation of that water has caused the buildup of natural mineral salts on the surface of the land, like you can see in the bottom image that I have here. There's a crust of salt that develops over top of the land that makes the land impervious to roots and uninhabitable by the bacteria that would normally provide nutrition to the plants. So we actually are desertifying land by using this conventional agricultural practice. So it can't be the productive solution for feeding the world because of its greenhouse gas emissions. And it's also destroying real estate, agricultural real estate that is much needed as we realize that we are losing this land all around. If we look at other ways, the fact that we have only annual crops with very shallow roots and they're only in growth for a short period of time means that a lot of the time we have bare soil. So even this image is not bare soil, but the roots are too shallow to protect against the rain. So when the rains come, we have massive erosion. The erosion actually can decrease your yield by 30 to 90% in most industrial farms. And the cost of soil erosion annually in the US is upwards of $44 billion. So to say that if we can stop just the soil erosion, forget about all the other reasons, forget about the greenhouse gases. And if you know that your crop, and these are arbitrary numbers that have no relevance, I'm just giving you a number. If we say that we need 100 pounds per acre of nitrogen, well, then you actually are told by your agronome to buy 200 pounds of fertilizer per acre, because we know that 50% of that will be lost through erosion and rain. We know that about half of your fertilizer will wash into the river, and therefore you have to double the need in order to have half of it remaining for those crops to grow. So how much does that cost? What is the annual cost of fertilizers that are wasted? And this is even, if you want to be ignorant and not talk about the ecological impact, just the economic impact of that is obscene. If you could reduce by half your cost in any department of any business, it's a huge, huge benefit, right? So if we can cut our costs by 50%, it's a major gain. The other issue is that that fertilizer makes its way into rivers and oceans, causing it to be uninhabitable, causing algae blooms, causing anoxic zones with no oxygen that cause fish kills, or the red algae that you may have heard about. These are all kinds of things that are a direct result of the agricultural runoff. And we don't, you don't think about erosion being a very large impact, but if we look at the image on the left, this is an image from Kansas in 1995 to 96. They had one windstorm in a dry winter that took off 2 inches of topsoil on 2.5 acres. And this is about 650 tons. Remember when we were in elementary, a ton is about the equivalent to an average elephant. So the 650 elephants worth of soil that just washed down the river. And that was only one storm on one farm on one winter. And that is what we're dealing with this conventional monoculture till-based agricultural system. It is wholly inadequate, and it is not providing for it can't even maintain itself. When we talk about sustainable, that's about maintaining something. Well, it can't even be sustainable, let alone something that's going to increase productivity. So that brings us to our next slide, which is, do we want sustainable agriculture? Do we want sustainable business? Do we want sustainable families? Or do you want a sustainable relationship with your best friend or your partner? If you had one, it would be okay, but it's not worth bragging about. Sustainable is bare minimum. Right? Sustainable is that you are sustaining things as they are. So if we sustained the amount of climate greenhouse gas emissions as they are today, is that okay? If we sustain the amount of soil erosion that we have today, is that okay? If we sustain the amount of illnesses that are generated by residual chemicals and pesticides in our food, is that okay? No, because none of this is actually where we want to be. Sustainability is the first step in a ladder towards abundance. What we want to get back to is this natural abundance that the earth has provided us with to be able to be a cognitively confused human species that we are today, contemplating, the stars and AI and all these other fancy fandangled things. And if we want to keep doing that, we need to reinstill this abundance that biology has provided us with. So we want to move away from this degenerative model into a sustainable model that has the goal of becoming a regenerative design model. So what is regenerative agriculture? Well, it describes specifically farming and grazing practices that are, among other benefits, reversing climate change by rebuilding soil organic matter and restoring degraded soil biodiversity. And that also results in both carbon downdraw and improving the water cycle. So it's a holistic land management practice that leverages power of photosynthesis, plants, and the carbon cycle to build soil and crop resilience and nutrient density. So the best part, I think, is at the end there, because even if it stops climate change, even if it stops the massive flooding, even if it stops all of these things, one of the most important things, I think, for me is that it is providing better food. It's not just even providing the same quality food that we currently produce in our agricultural model. It's providing food that has a higher nutrient density. And so I'm sure many of you have eaten a meal and you're physically full, but you're not actually, you don't feel satiated. And so there's this concept of we are obese and starving at the same time as a nation, right? We overeat in terms of calories and we undereat in terms of nutrient density. And if you look at the rough stats, there's all kinds of different ones for different plants, but apples have 10% of the nutrients that they did 70 years ago. Tomatoes have 50% of the nutrients that they did 50 years ago. And this is directly related to the soil health. If the soil is not healthy enough to support the plant can't generate the nutrients that we need. And the beauty about nutritious food is that you have the most complex scientific sensor in the world in your mouth, and it tells you when food is nutritious. Because if you've ever bought an organic carrot that tastes kind of bitter, it's not very nutritious. But an organic carrot that actually tastes sweet, that you don't even need to peel, that is something that has a very high nutrient density. And there's scientific studies that have shown very strong correlation between natural sugar production and the nutrient density of food. So I don't just want to fight climate change or stop erosion or have all these reduced pesticides. I also want better food. And I think that's a great thing to work towards. So regenerative agriculture, it comes with a toolbox of the different principles. So there's these 6 principles here: limiting soil disturbance, building soil diversity, armoring the soil. So this means living roots, living ground covers, and also dry organic matters that are inoculated, that are on the surface. Integrating animals, and this is where I differ very dramatically from a lot of people who talk about regenerative agriculture. Everyone talks about integrating of livestock. And it doesn't have to be livestock. In many permaculture designs, we have vegans who do not want to eat any animals, and that's absolutely fine. That's great in many ways. But you do need animals and insects present on your farm to be able to cycle different plant materials and organic matter into soil. And so you need to have the integration of animals, not necessarily a livestock that you're going to kill and eat. Then you also need increased wildlife habitat, so that can be part of this. There's a famous, images of these old farms in Egypt where they have this giant pigeon hotel in the middle of the garden, and they feed the pigeons so that they come and live there and poop in this big pile, and they use that poop just as fertilizer in the garden. So there's all kinds of different interactions that we can have with integrating wildlife and livestock into our farms. Whereas conventional agriculture, we want to keep every other living organism out of the farm except for the corn and the soy. And then we have designing for natural climate solutions. So we're not going to get into each and every one of these techniques, but we are going to look at what exactly regenerative agriculture is and what does it look like. So if we look at, how am I doing for time? I've got, oh boy. All right, so we've got, if we look at right now, 75% of the world's food supply comes already from small non-chemical farms that are about 2.5 acres on average. They're already using techniques. Not all of them are permaculture. Not all of them are certified organic. Actually, most of them are not. And not all of them are doing this because they want to be part of this movement. They're doing this because it's the best way to do it. In countries where poverty is paramount, you understand very quickly that chemical agriculture is a system of poverty. And in fact, using diverse, multi-species, multi-animal integrated ecosystems is a way better system of growth. So we have improved crop yields. We have increased soil organic matter. We have reduction and elimination of erosion. Some systems have no more soil erosion as a result of changing to these techniques. It actually builds soil. So we can take, and there are examples that we'll show you of areas that have had no soil or have had all their soil degraded and eroded away, and we can build soil back in those situations. There's techniques that I've seen people build on cement in a parking lot, and you use these techniques, and a year later we have 1.5 feet of topsoil because of the specific soil building techniques that we're following. It also increases the available nutrients, which then helps us in our food quality as well. So the next list of things is that it totally eliminates the need for synthetic pesticides, herbicides, and fungicides. And you may still have outbreaks, you may still have diseases, but very often the plants themselves have the ability to fight disease and fight pests on their own. And so why not leverage that? If you're an intelligent business person, why would you buy a Band-Aid solution when you can look at how to generate a solution on its own, which is the ability of the plants to heal themselves? And the only way that they can do this is with proper nutrient availability in the soil. This is something we can't really get into fully, but a living soil ecosystem provides a a plethora of different nutrients like molybdenum, which you need in 1 part per billion. Otherwise, you will have a specific plant disease. So by having healthy soil, we can actually have healthy plants that don't require these interventions nearly as much. We can reverse desertification, as many of the work of the List Plateau, Greening the Desert, and Alan Savory have done. Replenish watersheds and bring rivers back to life. There's examples of this in Rajasthan and in China. Increasing yields. Many people look at the studies that talked about how organic agriculture will give you 20% reduction in yields as a comparison to chemical agriculture. Now that's like taking a normal automobile and removing the oil from it and seeing how efficient it runs as a mechanism because it's an oil-free car. Well, if the car was designed to use oil, then it requires oil to function in the way that it's designed. So a chemical farm that you remove chemicals from is obviously not going to perform. But a holistically designed multi-species farm that is designed from the get-go to have a benefit of interactions of different plants, different soil organisms, different nutrients can actually outperform. And there are studies that have shown 100% to a 400% increase of productivity depending on the application and the climate zones that you're working in. So we can have massive increases in yield by incrementally adding these different ecosystem solutions, not let alone all the residual benefits that we have to the ecosystem and to our own homes. So there's many other things that it's doing, but let's look at some of the examples. So one of them is alley cropping. This is a very simple technique where we have rows of trees. You can see here, normally this would have been deforested, this hillside, and we would have annual crops here, and that in a heavy rain would cause a landslide, which would wipe out the village down below. So here we have rows of tree crops that have perennial root systems grown on contour so that when the water lands on them on the row, it actually distributes the water equally and passively irrigates. And in between there, we have annual crops that are in rotation with perennial crops that have a short light cycle. So this is an integration of these two things. One of my favorite presenters, authors, permaculturalists is Mark Shepard, and he actually has a farm that uses asparagus in the rows and hazelnut and chestnuts on contour in his cropland. And he talks about how hazelnuts, actually when you crush hazelnuts into a powder, that powder can be used just like soy. So not that I am a big fan of soy, but soy is in every processed food you can imagine. And if we could replace that with a hazelnut powder that you till the land once, you plant the hazelnuts and you get harvests for up to 50 years, instead of soy, which you are tilling every single year and you get lower yields over time. So it actually causes increased rainfall by interacting with the hydrologic cycle. It causes increased groundwater recharge, which means that your well won't go dry in those drought years. It prevents the floods by allowing that water to soak into the ground, prevents the drought by having that passive storage of water underground after those floods have been seeped in, and again, decreases the plant stress, which would result in disease or pest. Another famous regenerative agriculturalist is Gabe Brown. And if I don't know exactly when we started, but if you can just let me know how much time I have left, that will help me out.
Around 5 minutes.
Okay, perfect. All right, so everyone take a deep breath. Gabe Brown, he's renowned for being a farmer that was converted on his own accord. He was a big GMO chemical industrial farmer who through his own luck found this technique, and he's got, you can see from 1993 to 2013, 10 years, has increased his soil to 11% organic matter, which is a massive carbon sequestration. He's got a really good book called Dirt to Soil and some great TED Talks that talk about how this is not only something that you do for the future, something that you do for the planet, something that you do for food. It's actually something you do for yourself as a business person, because it does not make economic sense to keep applying these chemicals and fertilizers and pesticides that keep driving you further and further in debt. If we look at just regenerative agriculture and it's a possibility, this chart, don't get too far into it, is the actual reported carbon sequestration of different countries, but then the exponential or the extrapolation of what could be sequestered if we applied this technique to the farmland. We could, if we globally applied regenerative agriculture, and this graph is only talking about conventional till-based agriculture, not even talking about transforming our cities or our parks into regenerative agricultural urban spaces either. So if we just look at conventional agriculture, we can offset 37 gigatons of carbon every year. Now, what does that mean? Well, in 2018, we emitted 37 gigatons of carbon dioxide equivalents through the fossil fuel industry. So we are talking about not reducing your emissions by 20% or 50%. This is, we can knock out entirely the emissions by doing something that doesn't just fight climate change, it provides all these other benefits as well. So how does permaculture play into this? Well, in permaculture, we're not doing agriculture, we are doing ecological design. So in this little flower of solutions here, you see that land and nature stewardship is one of them, land tenure is another, but we can also look at buildings. So many people in the conference before mentioned greenhouses. Well, we can design and build a greenhouse here in Canada that does not require heating. So now how does that change the talk around growing tomatoes in the winter? If we don't need hydroelectricity to keep it warm. Tools and technologies. Well, there are old technologies that are being reinvented today with permaculture principles that are going to provide all kinds of different solutions. Education styles, health and spiritual well-being, financial models, all of these have solutions in permaculture that are rewriting entirely how we see the world today. So because permaculture is applied in all these different domains, it also means that it's harder to understand. So to give you a visual example, this is from Greening the Desert, one of my teachers, Jeff Lawton in Australia. So this is in the Jordan Dead Sea Valley on the left here. And this place in the world used to be known as the Fertile Crescent, or the land of milk and honey, or the breadbasket of the world. But because of deforestation and till agriculture, it's now a desertified area that has 400 times the salt limit for arable land. Now, by doing observation, if you're anyone who has a garden, you know that it's missing two things. You're missing soil and missing water. So we go ask nature, well, how do you get water in nature and how do we get soil in nature? So they dug a trench to catch the rainwater that lands on that area, and they filled it with organic matter, because organic matter is eaten by bacteria and fungi, mushrooms, to turn into soil. And 6 months later, this is what you see on the right. It's obviously a different climate, it has a different growing season than we have, but you can achieve that kind of transformation in 3 years here in Canada. So there's absolutely a paramount focus on this ecological design technique, because not only can we prevent the arable land that we have today from degrading, but we can reclaim desertified areas that were once lush, abundant ecosystems. And a new study has even shown that 5,000 to 7,000 years ago, the Sahara Desert was a tropical forest. So why not, with our human ingenuity and our need to cultivate more land, tackle the Sahara and turn that into our new green real estate? In the Luz Plateau, I have just a couple more examples. We see this entire river ecosystem that was dried up and didn't flow. And by applying permaculture techniques here, Jandi Liu and a bunch of people from IMF and other organizations transformed the entire ecosystem. And you can see it's not just the farmland, which is that horizontal plateau, but it's the entire ecosystem that is reshaped. And the rains come back, the fires stop, famine is down, poverty is down. And this is 60 years later, obviously, but these are massively transformational techniques of design. Here's another of that project's successes. And we have finally Alan Savory, who does all of this by not digging, not planting, not doing anything but moving the animals differently on the land. If we look at the images that we have of the bison flocking across the plains of Canada, of North America, northern Turtle Island, we actually would see thousands of these organisms moving like a herd. And today what we see with our sheep, with our goats, with our cows, is we see on 1 acre, them all spread out, spending their time eating everything down to the ground and ripping the roots out. And that causes desertification. So this image was taken in Mexico, in agricultural land that's, or grazing land, where they just run animals. And what they did was, instead of letting the animals just run free and eat whatever's green, they put them into a herd and they moved them every 3 days, like a normal herd would move. And that is the only change they did. They didn't do anything else. And in 2003, 40 years later, it's an entirely different ecosystem. So we don't even need to bring in big dams or grants or anything. All we have to do is get some solar net fencing and help move the animals as a traditional herd would. and you can massively reshape these ecosystems. So for the final little bit here is it's not all about farms and big ecosystems, it's also about our urban ecosystem. If we look just at Montreal, we have over 675,000 trees that are not in parks. These are in those squares on the side of the road. And if we just, now do not quote me on this because I'm not a proponent of monocultures, but if we planted those as walnuts, because we can now get the stats of production for walnuts, we can produce upwards of 20,000 to 100,000 tons of walnuts per year on the island of Montreal. It's a pretty impressive amount of nuts, right? Especially considering nuts are carbs and protein. So these are the two major elements of food. And you don't have to eat walnut everything. We can transform that into many different other crops and products. And they also keep really well. And they could also obviously be many more things than nuts. And the image that you're seeing here is the Beacon Food Forest in Seattle. And it's actually planted in the lowest income neighborhood in Seattle. And it's 7 acres. So that's 7 football fields of edible bushes, shrubs, nuts that are also catching the rainwater, building soil, building habitat, and feeding people in poverty without that need of an annual garden maintenance. So this is what it looks like. And it's something that is growing very rapidly, and they've even allocated more land to this project to let it go. So there's many different places we can start. The Drawdown is your best booklet to start. It gives you the top 80 domains that have the biggest impact on climate change. And if you look in the top 10 here, education for women is one of the most important. I think it probably should be higher than number 6, because they're often the ones who manage the food, who manage a lot of these other elements. But reducing of food waste, because currently we already produce twice as much food as the planet needs, managing refrigerant and all of these different things. But land use is still huge on this list. So really, what does it mean to be human today? It's a question that I need you to ask yourselves, because what we ask ourselves is, how many times do you take a flight? Probably not many this year, but how many times do you eat steak, or do you drive your Mercedes-Benz, or what is your environmental impact is usually a measure of how bad you are for this earth. When the question really needs to be, how many times have you planted a tree? How many discussions have you started with someone that shakes the current reality and starts bringing us forward as a species? How many times have you helped a grandmother in need with their groceries or with their Google account? How many times have you helped a friend out of depression or suicide, which is a huge growing problem around the world today? These are all things we need to be measuring, and understand that human beings, we're here today because we have massive positive impact potential, and we've had that as a historical past. This article that we're looking at here is showing how actually a large portion of the Amazon rainforest was planted and built by tribal peoples that lived in that area, and actually did a specific type of soil composting and planting fruit trees. In these areas, there's 20% more productive trees than there would be in a normal forest. So it's a forest, looks like a jungle to us, but it's full of nuts, full of medicine, full of fruits that are planted and maintained by those peoples. So we as humans have had many, many thousands of years of positive impact and a few hundred years of really destructive impact. And we need to wake up and remember that ancestry that we have and retake what it means to be human today. And if you want to do that, we have all kinds of ways that we can help you on that journey. The middle here is the Keys of Permaculture. It's 3 little free webinars that you can get on our website. We also offer an online, take it as you can, Fundamentals of Permaculture course, which is 10 hours of content plus 14 hours of supplementary video content. And then we end with a Q&A and live sessions to help you start your own projects. And if you really are tickled by permaculture and you want to bring this into your business design, into your architecture practice, into whatever you're doing in your life, then come and take the 2-week intensive certification. We do it on the farm where there's all kinds of people that are in a like-minded mindset of redefining what it means to be human today in these moments of change, moments of crisis. And it's not just stress about climate change, stress about COVID, stress about making money. It's actually a beautiful, empowering, fun experience. And to know that you're not alone in this, and that we are actually many, and we are moving in many groups around the world, is a very empowering thing to do. And it's important to support yourself and to give you that strength as we move forward in these changing times. The course covers all kinds of different elements. We're not going to get into it. If you want to, you can let us know later on, and we'll talk your ears off about it. As you can tell, I like to talk. So the last 2 things I'm going to give you are some homework to go home with. On Netflix, you can see Kiss the Ground, or you can order the book online or go to your bookstore. if it's open. Kiss the Ground is a really great documentary. It's actually narrated by Woody Harrelson, so that makes it more digestible to the general patriarchal white male dominated society that we live in today, if you like that kind of thing. There's also The Biggest Little Farm, which is a really great documentary on the transition of a desertified dead land in California into a productive permaculture paradise in 7 years. So that's it. That's all. If you want more information on courses, designs, or other speaking opportunities, let us know. It's our pleasure and our passion. And with that, I'll leave the rest of the time for questions. Sorry, I went over time.
No worries. We know that we will now pass it on to the Q&A section. We might not get all of the questions. I received a lot of great questions, so I'm sorry about that. I think we might do a video after for answering the questions. Graham, if you're still okay with that.
Yeah, and whether you guys are able to or not, I can just do my own recording of it. But as long as I have the questions, so as long as because I know that when we close the Zoom, it erases everything, right? So as long as we can have somebody who documents all the questions, and then whatever we can't cover, I'll do a little video Q&A, and we can post that as we post this video online as well.
Okay, yeah. So we'll just have time for one question. I'm really sorry about that. So I think it's a great question, especially here in Quebec. So the person asked, have you worked with the indigenous communities throughout your work with the permaculture design? While learning about ecology, this person have learned that in North America, before first contact, they actually maintain the land to promote growth, just like permaculture aims to do.
So I personally was raised in Nova Scotia on 72 acres of land, and we had one of my best friend's family was Mi'kmaq from Mi'kma'ki and in Buttonkick, which is a territory out in Nova Scotia. So I have had quite a bit of contact and experience through looking at different Indigenous perspectives. Most of the time when I work with Indigenous groups, I've done a little bit of work here and there. It's more as a seat of learning than a seat of teaching, because we actually, and not to say that they have all the answers or even that there's a unified they out there, because that's a whole thing we can get into. But there is a lot of Indigenous practices that have been lost, and they have been lost due to our brutal colonization through the all these brutal practices that we've done with the residential schools and so on and so forth, where we've erased a lot of this knowledge from even those communities who remain. But there is a lot of really beautiful stuff out there, like the fact that, if the early accounts of the forests, they talked about how there was this abundant wilderness of food, and all around Lake Ontario, it was supposedly a peach grove of wild food. Well, none of that was wild. It was a maintained edible forest garden that was maintained by the people. And an example of this, when I was in my, I don't know how old I was, but I remember hearing that apple trees are considered sacred by the Mi'kmaq. But the irony is that an apple tree is an invasive species that was brought here by the white man. It originates from Kazakhstan. So how could that be a sacred tree in Mi'kmaq culture? Well, because their culture is not static like the Bible, it's evolutionary, it grows and it adapts and it moves on. And what they've noticed is that the apple tree always gives food. And if you've ever looked at an apple tree in the middle of winter, a lot of the dead branches are still in the tree and it looks like a mess. But you can break a tree off in the middle of a snowstorm, and a branch, and that tree branch is bone dry, which is really hard to find dry firewood in the middle of a snowstorm in Canada in the woods. So if you're lost, you got to find those wild apple trees that have become wild, and you have a source of firewood. So it's become sacred because their ways of life are built upon observation and respect of ecosystems. And so as the ecosystem changes, that respect and those practices evolve and change as well.